Welcome to Engineers Academy. Subscribe to my channel and click on the bell icon to receive the notification for the upcoming videos.
I am going to solve this sample problem from chapter number 4. This is the first problem of chapter 4. In this problem we are asked to determine the forces in each member of the loaded cantilever truss by the method of joints, right? So we are going to apply the method of joints to find the forces in each and every member of this cantilever truss, right? So to solve this problem, first we have to find the reactions at the supports, right? So we have this support and we have this support, right? So if we isolate this member of this truss from this support, so then we will have tension, right? So we will have tension in this direction, right? So here we will have tension like this. Let's say this is the T, right? And similarly we will have two reactions at this point E. So one reaction will be in this direction, right, and one reaction will be in this direction, right? And let's say that this is our positive x direction and this is our positive y direction. So then we can say that this is Ex and this is Ey. First we will find this T, Ex and Ey, right? So for that we will apply the equilibrium condition. So now if I apply the summation of moment at point E equals to 0, so when we apply this condition, so these Ex and Ey are not producing the moment about this point E, so we can find this T, right? So and if we assume that the counterclockwise moment is positive, so as we can see that this 30 kilonewton force is producing counterclockwise moment about this point E, and this 20 kilonewton force is also producing the counterclockwise moment about this point E, and this T is producing clockwise moment, right? So if I write that this is minus T and the perpendicular distance of this T from this E is this 5 meter, right? So this is perpendicular with this member. So I will multiply this T with 5, right? So I will write 5T. Let me write it as minus 5T, and this 30 kilonewton force is producing counterclockwise moment, so I will write plus 30 kilonewton, and the perpendicular distance of this 30 kilonewton from this point E is 5 plus 5, so this is 10. So I will multiply this with 10, and again this 20 kilonewton force is producing the counterclockwise moment about this point E, so I will write plus 20, and the perpendicular distance of this 20 kilonewton force from this point E is 5 meters, so I will multiply this with 5, so this will be equal to 0. So when we solve this equation, so then T comes out to be 80 kilonewtons. So now we know this T, this is 80 kilonewton, right? And now we can find this Ey and Ex. So first before that, if we apply this summation of forces along x equals to 0, but before applying this equation we have to find the components of this T along x and y axis, right? So let's say that this is the positive x direction, right? So we have to find the angle of this T with this x-axis, right? And as we can see that all the members of this truss are of equal length, right? So all the members are of length 5 meters. So this means that all these triangles are equilateral triangles. So this means that this angle is 60 degrees, right? All the angles are equal, right? So we have to divide 180 by 3. So the equilateral triangle has angles of 60, 60, 60, right? So if this angle is 60, so this means that this angle is also 60, and if this angle is 60 and this is 90, so then this angle is 30 degrees, right? Now we can resolve this T force into its components, right? So we will have one component in this direction and then we will have one another component in this direction, right? So this one will be the Tx component, this one will be the cos component, right? So if we write that this is 80 cos of 30 degrees and this one is 80 sine of 30 degrees. So now if we apply the summation of forces along x, so as we can see that we have only this component along x, this is in the positive x direction and this one is in the negative x. So I will write minus Ex, and this one is in the positive, so I will write plus 80 cos of 30 degrees equals to 0. So this means that from this equation we can find Ex will be equal to 80 cos of 30 degrees. And similarly, if we apply the summation of forces along y-axis is equal to 0. So now we have this component in the positive y, we have this component in the negative, this component in the negative, and this Ey is in the positive y direction. So I will write Ey, which is in the positive y, then I will subtract this 30 kilonewton, it is in the negative y, so I will subtract it, so this will be 30, and then we will subtract this one as well, so this will be minus 20, and then this one is in the positive y direction, and this one is 80 sine of 30, so I will write plus 80 sine of 30 degrees equals to 0, or if we bring all these constants towards the other side of equation, so all these will become plus, right? So we will have plus and this will become negative, right? So this will be negative, so this will give us Ey. So let me find this Ex and Ey by using calculator. Okay, so when we solve these equations, so then Ex comes out to be 69.28 and this Ey comes out to be 10 kilonewton, right? So now we know these reactions, so let me write that this Ex is 69.28 kilonewton and this Ey is 10 kilonewton, right? So now we will start with this joint A. So if I write that joint A, so now since this whole truss is in equilibrium, right? So remember that whenever there are three forces at a joint, so then when the system is in equilibrium, so those three forces will have such direction so that they will make a closed triangle, right? So as we say that when the system is in equilibrium, then the summation of forces is equal to 0, right? So this is the equilibrium condition, right? So when three number of forces have the summation equal to 0, so then they will make a closed triangle, right? So if this is the 30 kilonewton force direction, right, so we cannot change the direction of this, but we will select the direction of the forces in this AB member and this AC member, right? So we have to identify the direction of this AB force member and this AC force member, right? We will try to assume such a direction so that the summation of these three forces by a head to tail rule will give us a closed triangle. So if I draw this line, right, this is parallel to AC, and then if I draw another line parallel to this AB, let's say that, so then we will assume such direction so that the resultant so that they will make a closed triangle, right? So if we know the direction of this 30 kilonewton, right, so if I draw that 30 kilonewton force, so that 30 kilonewton is vertical and we know the direction of that 30 kilonewton force, so we cannot alter the direction of this 30 kilonewton force, right? So this is 30 kilonewton force. Since the joint A is in equilibrium, so these three forces will make this closed triangle. So in order to make this closed triangle, so this is that AC, so then the force in the AC member will be directing in this direction, and then this force, this AB force will be in this direction, right? So they are making a closed triangle, right? So the resultant of these three forces is equal to 0 when they make a closed triangle, right? So we will always try this method whenever we will have three forces in a particular joint, on a particular joint, right? So these are the directions of that forces in this AC and AB member, right? So if I now draw this force, so this AC force is in this direction, and this this AC force is in this direction, and this AB force is in this direction, right? So now using this triangle we can find this AC and AB, and as we can see that this angle is 60 degrees, right? So this angle is 60 degrees, so this is that AB. So if I draw a horizontal line here, so this AB is making 60 degrees with the horizontal. So if this angle is 60 degrees, so then this angle is also 60 degrees, and this is 90 degrees, right? And the summation of these three angles will be 180 degrees. So if this is 90, this is 60, so then this angle will be 30 degrees, right? So now we can find this AC and AB by using this triangle, right? Since it's a right angle triangle, so this means that the cos component, this A, we can say that we can find the magnitude of this AC and AB. So we can say that AB cos of 30 degrees, right? So this AB cos of 30 degree is equal to this 30 kilonewton, right? So we can say that AB cos of 30 degree is equal to 30 kilonewton, right? So now we can find this AB. So AB will be equal to 30 divided by cos of 30 degrees. So this will give us the magnitude of force in the AB member, right? So this is AB. Similarly, we can see that this AC is the sine component of this AB. So we can write that AC is equal to AB sine of 30 degrees, right? Or we can say that this AB is 30 by cos of 30. So we can say that this AC is AB, and we know this AB is 30 by cos of 30. So I can write that this is 30 divided by cos of 30 degrees sine of 30 degrees, and this sine by 30 is 10, right? So we can say that this AC is 30 10 30 degrees, right? So this will give us AC and this will give us AB. Or we can find this AC once we know this AB, right? So first we can calculate this AB, and then using that value in this equation, so then we can find the magnitude of that AC force. AB comes out to be 34.64 kilonewton and AC comes out to be 73.32 kilonewton, right? So now we know the magnitudes of AB and AC, right? So this is AB and this is AC, and these are the direction of AB and AC, right? This is one method, and this method is applied when we have only 3 forces at a given joint, right? Otherwise we can apply the summation of forces along X and the summation of forces along Y, right? So if I apply that method to joint A, so then I have to draw this diagram again. So if I draw that diagram, let's say that this is joint A and this is the AC force, and let's say that this is AB force and this is that 30 kilonewton force, and this AB is making 60 degrees, right? So now first we have to resolve this AB into its components. So then it will have one component in this direction and then it will have one component in this direction. So I will write here, right? So but this purple arrow is on the top of this, right? So I draw it so that it is visible to you people, right? So this is the component of this AB, right? So this is ABX and this is ABY. Now if we apply the summation of forces along Y equals to 0, so then as we can see that this is ABY. So ABY is the AB cos sine of 60, right? This is the sine component. So we can say that ABY minus 30 kilonewton is equal to 0, and this ABY is AB sine of 60 degrees, and this will be equal to 30 kilonewton. So this means that AB is 30 divided by sine of 60 degrees, and this should give us this same answer. So this AB again comes out to be 34.64 kilonewton, right? So this method is also accurate, but this method needs some step and also need to find the components of all the forces in each member, right? So this method is I prefer this method, right? So this is the summation of forces along Y, and now if you apply the summation of forces along X equals to 0, so then as we can see that this ABX is in the positive X direction, so we can write that this is ABX and this ABX is AB cos of 60 degrees and this AC is in the negative X, right? So I will write minus AC equals to 0, or we can say that AB cos of 60 is equal to AC, or we can say that AC is equal to, since we know this AB, so then this will be 34.64 cos of 60 degree, and this will give us that same AC, which is 17.32 kilonewton, right? So you people can use both of the methods, right? Now once we know the magnitude of this AB and AC, the forces in these two members, so then we have to specify whether this AB is tension or whether this AB is compression, right? So this is the force, this AB, this direction of force is the force applied by the member on the joint, right? So this is the force applied by the member on the joint. So as a reaction, the joint will apply the force on the member, right? So let's say that this is that AB member. Let's say this is that AB member. So as a reaction of this force, this joint will apply a force in the opposite direction, right? So this will be the force on this AB member, right? So this force, as we can see that this force is trying to elongate this AB member. So this means that this is the tension force, right? So whenever the force AB is away from the joint, so this means that that will be the tension force, right? So we can now specify that this is the tension force, right? This AB is the tension force, and whenever the force is acting towards the joint, so this means that the member is in compression, right? So if we consider this AC member, right, if this is that AC member, let's say, so this is the force on the joint. So as a reaction, the joint will apply the force on this AC member in this direction, right? So this means that this AC member is in compression, right? Its length will decrease, right? So we can say that this AC force is compression force. So again, whenever the force is away from the joint, so that will be the tension force, and whenever the force is towards the joint, so then that will be the compressive force. Now we know this AB, now we know this AC, and since as we know that this force will remain the same, this force will remain tension force, right? So this means that here at this joint B, the force will be in the opposite direction, right? Again, if I draw that member again, right? So let's say that this is that AB member. So the forces on this AB member is the tension force, right? So we will have this force and we will have this force, right? If this is in tension, right? So this force is in, this AB member is under tension, right? So this is the forces on this member, right? So this means that the force on joint B will be in the opposite direction of this force, right? So this means that this force and this force will be in the opposite direction, right? So on joint A, this AB force will be in this direction, and at joint B, this AB force will be in this direction, right? So we can specify that we know the direction of AB at this joint, right? So now we can find the remaining two forces at this joint B. So now we have to consider this joint B. So if I isolate this joint B from this whole trusses, right? So let me isolate this joint B now. If we isolate this, right? So now we only know the direction of this AB force at this joint B. So again, we have to assume such direction of this BD and this BC, so that the summation of these three forces by head to tail rule should give us the closed triangle, right? So now let me draw these forces. So let's say that this is that BD, and let's say that this is that BC. Let me write that this is that BD, and let's say this is that BC. So then this will be AB, right? And we cannot change this AB direction, right? Since this, we know that the direction of AB is in this direction, right? So these three forces should make a closed triangle. So then this BC should be in this direction, and this BD must be in this direction, right? So this makes a closed triangle by head to tail rule, and the summation of these three forces is 0, since this joint B is in equilibrium, right? So we can say that this BD force is in this direction and this BC force is in this direction, right? So now we have specified the direction of this BD, this BC, and this AB member forces. So again, we can specify these angles as well. This angle is again 60 degrees, since all the triangles are equilateral triangle, and this angle is again 60 degrees. So we can use those two methods, right? So either we can use the summation of forces along X and the summation of forces along Y. So if I use the closed triangle method, right, so we can draw that this BD force is in this direction, right. So let me draw this BD force, let me draw it here, right. So this is that BD, and let me draw that AB force. So this will be that AB force, and then this will be that BC force, right. So this is, I will write that this is BD, this is BC, and this is, sorry, this one is AB, right. We cannot alter the direction of AB, so this is AB and this one is BC, remember, right. Now since this AB is making 60 degree with the horizontal, right, so we can say that this is that AB, so this angle is 60 degrees, right. So if this angle is 60 degrees, so this is also 60 degrees, and similarly we can see that the angle between BD and BC is also 60 degrees, so this angle is 60 degrees as well. So if this is 60 and this is 60, so then this angle is also 60 degrees. So this means that this is an equilateral triangle, right. So now it is very easy for us. This means that if this is equilateral triangle, so then AB is equal to BD is equal to BC, right. So we can write directly, right. So we know AB, so BC is equal to BD is equal to AB, and AB is 34.64 kilonewton, right. So this is the magnitude. So now we have to specify that whether BD is tension. So we can write that BD magnitude is 34.64 kilonewton, and from this direction we can say, since this force is away from the joint, so this means that this is tension, right. This will elongate the BD member, and then we can say that if we write that BC, so the magnitude of BC is again 34.64 kilonewton, and as we can see that this BC force is towards the joint, so this means that this is compressive force, right. So now we know this BD and we know this BC member forces. Now we will consider joint C, right. So we will consider joint C. So let me isolate this joint C from the remaining members, right. So now we have more than 3 forces, right. So then it will be difficult for us to specify all the direction in the correct direction, right. So since we know the direction of BC, so this BC is towards the joint B, so here it will be towards the joint C, right. So we know this direction, right, BC. We know this AC direction, right. So since this AC direction is towards joint A, so it must be towards joint C, right. So now we have to assume the direction of this CD and this CE. So let's say that this CE is in this direction, and let's say that this CD is in this direction, right. So these are the assumed direction. If these assumed direction are incorrect, so then we will get the negative sign with these force member forces, right. So now if we apply the summation of forces to joint C, so then first we have to resolve these forces. So let me draw this free body diagram here, or let me draw the components of these forces. So then this force is, let me write, this is CD, this one is CE, right. This one is BC, and we know the magnitude of BC, which is known, right. So this is 34.64, and this is AC, right. So we know the magnitude of AC as well. So if we resolve this CD force into its components, so then this CD force is making 60 degree and this BC force is making 60 degrees. So this CD force will have one component in this direction, right. Let me draw it a bit large here, right. So let me draw it here. So let's say this is that AC and this is that joint C, and then we have this CE, and then we have a force at this point, let's say this is that CD, and then we have another force which is in this direction, right. So this force is BC, and let me write the magnitude of this is 34.64, right? And this AC, the magnitude of this AC is known, which is 17.32 kilonewton, right? So all of these are in kilonewtons, and this angle is 60 degree and this angle is 60 degrees. So now if I apply the summation of forces along y equals to 0, and remember that we have this 20 kilonewton force as well at this point C, so we have to draw that as well, right? So this is that 20 kilonewton force. So now if we apply the summation of forces along y, so we have to resolve this CD. So this CD force will have one component in this y direction, and this BC will have one component in this direction. So we can say that this is CD sine of, this is CD sine component, so this is in the positive y, so I will write CD sine of 60 degree. This is towards the positive y, this one is towards the negative y, right? So this one is BC minus BC, and we know the magnitude of this BC, so this will be 34.64 sine of 60 degrees, and this force is in the negative y, right? So I will write minus 20 kilonewton, and this is equal to 0, right? So now we can find CD from this equation, right? So CD will be equal to 34.64 sine of 60 degree plus 20 divided by sine of 60 degree. So this equation gives us CD equals to 57.70 kilonewton, and since this CD force is away from this joint C, so this means that this CD force is in, this is tension force, right? Now we can find CE by applying this condition, that is the summation of forces along x equals to 0, right? And this is our positive x and y direction, right? So this AC is in the positive x direction, so I will write that this is 17.32 kilonewton, and similarly this BC will have one component in this direction, right? And this component is the cos component, right? So we can write that this is plus, let me write it here, right? So we have many components, right? So this 17.32 plus this BC cos of 60, right? So I will write 34.64 cos of 60 degree, and this CD will have one another component in this direction, right? So this is again the cos component, so I will write plus, this is in the positive x, right? So I will write plus, and this will be CD, and we know the magnitude of CD, this is 57.7, so I will write 57.7 cos of 60 degree, and as we can see that this CE is in the negative x direction, right? So we will write minus CE, and if we bring this will be equal to 0, and if we bring this CE to the other side of the equation, so this will become plus. So we can say that this CE will be equal to the summation of these three forces. So when we solve this equation, so CE comes out to be 63.49 kilonewton, and as we can see that this CE is towards the joint, so this means that this is compressive force, right? So this is the magnitude of CE, right? So this is CE. Now we can solve this joint D and this joint E as well, right? So if I solve this joint E, let's say first, so first we have to separate this E joint, right? So at this point E, now since we know this CE, so this CE is acting towards this joint C, so it will be acting towards joint E, right? So this will be the direction of that CE, and we do not know the direction of this DE, so let's say that this DE is acting in this direction. I will write that this is CE and this one is DE. So now again if I apply the summation of forces along x and y at this point, at this joint E, so let me write that at joint E, and if we apply the summation of forces along y equals to 0, summation of forces along y equals to 0, so we will have the component of this DE in the y direction, right? So let me write that this is the DE. So this DE will have one component in this direction, right? So this component will be in the negative y direction, right? So this EY is in the positive y direction, so we will write 10 kilonewton, and this one is in the negative, and this one will be the sine component, right? Since we have this 60 degree, so this component will be the sine component, right? So this is DE, right? So this will be DE sine of this component will be DE sine of 60 degree, right? So I will write minus DE sine of 60 degree equals to 0. So we can find DE, right? So DE will be equal to minus 10 divided by minus sine of 60 degree. So this will give us the DE magnitude. So now when we solve this equation, so DE comes out to be 11.55 kilonewton, right? And as we can see that this DE is towards the joint, so again this is the compressive force, right? So we will write that this is the compressive force. We have found all the forces in all the members, right? So we can count our members as well, right? So this is this is 1, this is AB, we know AB, this is 2, 3, 4, 5, and this one is 6, and this one is 7. So we have 7 members, and now we know all the forces in all the members, right? So this is 1, 2, 3, 4, 5, 6, and 7 forces, right? So this is the solution of this sample problem, and I hope you people would have understood this method of joints. Again, I would request you people that kindly subscribe my channel and support my channel.